Okay, here's example 7 with reference angles, so a little bit more complicated. We're kind of going to approach this like example 5 though. So anyway, example 7, find the reference angle for 13 pi over 8. So 13 pi over 8, so that's not a nice angle on the unit circle, right? These are all something over 3, over 4, over 6, over 2. Now we have something over 8. So we'll see that it's a little bit different, but we are going to start off the same way we always do, which is we ask ourselves, is this between 0 and 2 pi? Well, first of all, it's clearly larger than 0, so we're okay there, right? It's not a negative number. So now we say, okay, 2 pi is the same thing as, so multiply by 8 over 8 to get a common denominator. So this is 16 pi over 8. Well, hey, yeah, 13 pi over 8 is less than 16 pi over 8, because 13 is less than 16, okay, so we're good there. So, yeah, this is between 0 and 2 pi, so the next step is to draw it. Okay, so how do we draw something like this? This is where we approach it like example 5 now. Because remember, in example 5, we did the same thing with finding a reference angle. We did the same thing, but it was 233 degrees instead. So 233 degrees is not a nice angle on the unit circle, but we can approach it the same way. Okay, so what we're going to have to do in this case is, just like in example 5, we're going to say, okay, but now with radians instead of degrees. So we say, all right, let me try and bound this between two of these guys so I can stick it in a quadrant somewhere. So here, pi over 2 radians, so remember, start here, vertex at the origin, initial side on the positive x-axis, because we're talking about angles in standard position. So what we do then is say, okay, pi over 2 radians puts me up here. So here's pi over 2. How does that compare to 13 pi over 8? Well, get a common denominator. So that's 4 pi over 8. Okay, multiply by 4 over 4, so I get common denominator of 8. 4 pi over 8 is less than 13 pi over 8. So 13 pi over 8 is larger somewhere over here. We're not sure yet where. So let's keep going. Well, pi radians puts me over here. And again, I want to compare this to 13 pi over 8, so I have to get a common denominator. So multiply this guy by 8 over 8, and I get 8 pi over 8. Okay? Well, hey, 13 pi over 8 is still larger than that, so keep going. Go to the next one. 3 pi over 2 puts me all the way down here. So this guy is 3 pi over 2. But again, I want to compare 3 pi over 2 to 13 pi over 8. So I have to get the common denominator here, so multiply by 4 over 4. And I get 12 pi over 8. Okay? So 13 pi over 8 is still larger, right? So I have to go to the next one. Well, what's the next one? It's 2 pi, which actually we already talked about that. 2 pi is 16 pi over 8. And we already know, okay, we just talked about that before we started drawing this. We already know that 13 pi over 8 is less than that. So actually what we just found out was that 13 pi over 8 is somewhere in the fourth quadrant, okay, because 12 pi over 8 is less than 13 pi over 8, which is less than 16 pi over 8. Okay? So we know that 13 pi over 8 is somewhere in here in quadrant 4, and it's going to be closer, a little bit closer to 12 pi over 8. But again, we don't have to be exact. Okay, we don't have to get it exactly right or exactly to scale or anything like that. We just want to get the quadrant right. Okay, so this is 13 pi over 8. Right now, again, how do we do that? Why do we do that? Well, because 13 pi over 8 is not a special or a nice angle on the unit circle, so we're not really sure exactly where that is. There are a few different ways of thinking about it, but the way I like to do it, the way that's most generally applicable, I think anyway, is just say, okay, pi over 2 puts me here. How does that compare to 13 pi over 8? Well, get a common denominator. We're good. Okay. 4 pi over 8. Then 13 pi over 8 is still larger. Go to the next one. Pi is the next one. Common denominator, that's 8 pi over 8. Well, 13 pi over 8 is still larger. Go to the next one. 3 pi over 2 is the next one. Common denominator gives me 12 pi over 8. 13 pi over 8 is still larger. Go to the next one. The next one's 2 pi, which we already talked about earlier, was 16 pi over 8. So that's finally 13 pi over 8 is less than that. So I know 13 pi over 8 has to be somewhere in between these two guys here. Okay, so in right here. Okay, so now we can continue like normal. So even though it's not a nice angle on the unit circle or whatever, we can just keep going like we always do. So it's in quadrant 4. How do we get reference angles for something in quadrant 4? Let's zoom back in here. So first of all, what is the reference angle? Well, it's this guy right here. That's our reference angle. Remember, it's the acute angle between the terminal side of the angle we want, or the angle we have, and the x-axis. So that's the acute angle here. Okay, between the x-axis and the terminal side of our angle that we start with. Okay, so to get that, we go all the way around 2 pi. Okay, we go one full revolution, which is 2 pi. Subtract off this piece, so that we'll just be left with this. Okay, so go 2 pi, subtract off this piece, which is 13 pi over 8, and we'll just be left with this. Okay. So if we go 2 pi, subtract off 13 pi over 8, then we'll be left with what we want. And remember, 2 pi is the same thing as 16 pi over 8, so we talked about that twice already. 2 pi is 16 pi over 8. So this is 16 pi over 8 minus 13 pi over 8, which is 3 pi over 8. Okay, now if you've been following along with the other examples, you might have noticed this is slightly different now. Because remember, in the other examples, what were the answers? They were, except for example 5, they were things like pi over 4, pi over 6, pi over 3, pi over 6 again. So things like that. But we also pointed out a couple times that that's only true for those special angles like a number times pi over 6, a number times pi over 4, a number times pi over 3. So all these angles on the unit circle and all of their coterminal angles, their reference angles are pi over 3, pi over 4, pi over 6, things like that. But we also said for goofier angles, stuff over 8, over 9, over 12, over 7, over 5, over 9, I think I said 9 twice, it could be different, right? And we see an example here where it actually is different. So you might have expected, oh, it's something pi over 8, so the reference angle is going to be pi over 8. Well, that is not always the case for stuff over 8. And we just saw an example where the answer is 3 pi over 8. Okay? So again, this is example 7 with reference angles, slightly more complicated. And the reason it's more complicated is because 13 pi over 8 is not a special nice angle on the unit circle. So we can't just look at a unit circle and say, oh, 13 pi over 8, there it is. Okay, we had to think about pi over 2. How does that compare to 13 pi over 8? Pi, how does that compare to 13 pi over 8? 3 pi over 2, how does that compare to 13 pi over 8? And so on. Okay, so when you deal with goofy angles like this, that's what you have to do. Do the common denominator thing. See how the angles here, here, and here, and here compare to the given angle. Okay, so that's what we do there. So that's example 7, and again the answer is 3 pi over 8. Another example coming up in the next video.